those are some of the prospects of the experiment.
Yeah, well, and actually we have, of course, we have air in it.
Can you repeat that?
We have air in this cup, of course.
Okay.
Okay. And of course, the speed of the sound is very important.
Yes, the speed of the sound is important.
What are the important parameters for the speed of sound?
Alright, the main parameters probably for speed of sound is firstly humidity, and secondly it's the temperature inside the room. There are both numerical calculations to how the velocity of the sound changes.
Yeah, and actually the adiabatic index, isn't it?
Adiabatic
Adiabatic index, of course, defined as the degrees of freedom plus 2 divided by freedom plus 2.
Can you explain how that's correlated to the initial velocity equation, which is supposed to be the square of the bulk modulus divided by the density of the material?
What's the speed?
What?
What is
Bulk
the speed?
modulus. So this is the equation for sound. Can you please explain, for better discussion, how this correlates to either the density or the bulk modulus so that the jury can understand how this has changed?
I would say the velocity of sound is the root of the adiabatic index times pressure divided by density.
Right, so perhaps these two constants are the same concept that we're trying to use. Alright.
Pressure is not really a constant, but
okay.
Well, let's say so in a moment. But actually, you mentioned once that the delta frequency, the difference of frequency is 0. What do you mean actually about this? Actually, it can't be
the delta
zero
frequency
because just let me prove this. You mentioned in your presentation that delta F is 0.
Delta F is 0 for the case when the cup is submerged underwater. So what I was meaning for equations of delta F equals 0 for standing waves was that it changes when it's above water but smaller than the difference of 0.61 R. But if it's submerged underwater, because there's an insignificant amount of the influx of water creating a pressure.
Actually, if we push the cup
yes.
part of the water, of course we have a different pressure.
Yes, the pressure is gradually increased.
Maybe just give us a short sketch of your experiment. Sketch of it.
For when it's submerged or for when it's
top of the wall. Okay. Doing the water surface and so on.
Perhaps it's better to show you a picture.
Maybe give me a sketch. It's sketched in class, please.
All right. So.
I'm running out of time.
Sketch.
Yeah, please.
Consists of a cup and a sound sensor for underwater, placed like so, and a water cavity like so.
Yeah, and there's a ball in the cup.
Huh?
There's the ball in the cup.
The water only comes in an insignificant amount, like about this much, and this increase in the height is very minimal.
But for wavelength, this is quite a big value, isn't it?
It's not comparatively I actually have numerical calculations for how much the water actually comes into the cup.
Yeah, well, let's go on. This wasn't a question. Please let's go on. And actually, if we have just a bigger pressure here, then the gas is cooperating, isn't it?
Yes.
Yeah. So actually, we would have a bigger pressure in the gas. How is this influence on this velocity of the sound?
Okay.
Or
there is a pressure term in the change in the sound velocity. I completely agree to that. But if you see that minimum changes in the pressure, which I calculated in this cup to be about 0.1 kilopascals.
The pressure influences the speed of sound.
The pressure influences, but it's insignificant because there's only a change that I calculated to be about 0.1 kilopascals. And in terms of affecting sound velocity,
it has influence. Okay,
very small influence.
Actually, the task test in terms of sound. What is sound actually? Sound is more than just amplitude and frequency.
Yes, it is.
Yeah, of course. And what are the other characteristics of qualities of sound?
There may be characteristics such as the differences between a violin and a viola, which is the timbre of the sound, some of the sound patterns, and there are many other components such as loudness.
Actually, there has to be some intensity and some pressure. And this pressure actually doesn't have an influence on the pressure of the sound.
It influences perhaps at a very, very minimum scale, but in terms of the major dominant frequencies, very little change. Yes, I actually calculated the increase in the pressure. That was only 0.1 kilopascals.
That's actually your measurement errors are quite big. Actually, we aren't so sure if your theory is correct or your experiments are fundamentally wrong.
Which errors are you particularly talking about?
you have no numbers on the slide, so I can't actually remember. But there were some graphs, and the errors didn't reach the graph in the theoretical approach.
Some of the data points actually quite well matched the experiment. Some of the points that did not match, I explained I had explanations for why some of the errors existed. For example, the standing wave frequencies below water, you can see that the error bars quite well overlap with the theoretical data here. For some of the points, such as the standing wave frequencies, there may be some of the points that exist at a discrepancy. And if these are the points you're talking
actually,
about...
It's quite bad, in fact. But, this actually is a problem. But I think that there are many other qualities of sound that could be...
Right.
But actually, I hope you could improve your presentation a bit, because that is actually the purpose of this discussion. Thank you for the nice discussion.
Thank you very much.
Okay, thank you very much for the discussion.
So, welcome together. May I have some questions to the reporter and the opponent? First, the surface tension. Will there be an influence of surface tension if the cup is nearly above or nearly below the water surface? First to the reporter.
I believe there may be the influence of surface tension in terms of creating what types of modes of waves are created on the water surface. But in terms of influences being the standing waves or the major thin plate vibrations, the effects of the what you just said would be nominal.
Okay, what did the opponent say? Is there a clear on the surface definition?
Yeah, actually it's quite hard because the capillarity force actually trying to catch the beaker. Actually it hasn't really reached the surface. So, but actually you can say if there's no connection between the air outside and the air between, actually you can say something like this.
Okay, thank you. Then to go on to the reporter,
right.
What will the overtones of your frequency be?
Alright, for standing waves in a one-end closed cylindrical cavity, the overtones are mostly the third harmonics and the fifth harmonics, which are about approximately 3 times the size of the fundamental frequencies.
Okay, are the overtones harmonic?
The overtones are... Can you repeat your question?
Are they harmonic?
Yes, they are.
Okay, what do you think about this?
Harmonics? Sorry?
Is the overtone of the frequency harmonic? So is it a harmonical oscillation?
Actually, yeah, the plate of the beaker is also...
Yeah, but the whole system.
The whole system probably is a cross-band, but harmonic.
Okay.
There might be differences in plate vibration. I was only talking about the standing waves.
Okay, then to another influence. If the cup is below the water surface, then there will be some vibrations on the water surface, and there will be may also be some drops coming out of the water and attached to the side walls. Will this have an effect to the reporter?
My experimentation was mainly used to control the sidewall vibration. And so, because the sidewall vibration isn't really a dominant factor in generating sound, I think the water attached to the sidewalls will have an infinitesimal amount of influence.
Okay, thank you. Then to your measurements. You did the fast Fourier transformation, as I have seen.
Yes.
Did you use which type of the Fourier analysis? Did you use an absolute value of the complex number or the real part?
The absolute value.
The absolute value, okay. Then, how good is your reproducibility of the measurements?
Seeing from, firstly for cups with different length, you can see that some of the error bars are actually contained inside the points. For many of the points, that was the case. So the phenomenon would be quite reproducible in my case.
Okay, thank you for the questions.
Thank you very much. So we have the questions from the reviewer, and now we have the time for preparation for him.